Basic arithmetic number 6, fractions, decimals and percentages, and in this case we're looking particularly at recurring decimals. So what we want to be able to do is to turn a recurring decimal into a fraction. Once we can demonstrate that any recurring decimal can be turned into a fraction, we can be confident that whenever we see a recurring decimal, we know that it's a rational number. So here's our first example. We've got 0.4 repeater. The first step is to say that n equals 0.4 repeater. Once we've established that n equals 0.4 repeater, the next thing to do is to say, well, if n equals that, then 10n will equal 10 times that number. Once we've done this, we've got 10n equals 4.4444. What we now do is we subtract n from 10n. So in the next line we have 10n minus n, and if we look carefully you'll see that that means all of these decimal points here, all these decimal places, are going to eliminate one from the other. Once we subtract this first value for n away from the value that we've now found for 10n, we'll see that all of those decimal place values will disappear. So what we're going to be left with is just 4 minus 0, which will be 4. But looking at this 10n minus n, you can see that that is also going to be 9n. And as we can see from the previous line, 10n minus n is equal to 4. That means 9n is equal to 4. What I want to do is try and find out what n is. If I divide both sides by 9, then we'll have n is equal to 4 over 9. But we already know from our first line up here that n is equal to 0.444 repeater. So we've now found that our recurring decimal of 0.444 repeater is equal to 4/9. Let's have a look at our second example. We've got 1.329 repeater. So what we'll have is n equals 1.32929929 repeater. Continues on. What we have to do is to multiply n by a big enough number to make all of the decimal places shift over 2 places. That way we'll end up with an alignment of the 2 9 digits between one number and the next. What this looks like is 100n will equal 132.92929929, and the repeater continues on. This time, if we look carefully, all of these digits are now in alignment. That means if I do 100n minus n, if I subtract the value of n, this value here, from 100n, then all of these decimal place values will eliminate. So let's do the subtraction, and we'll end up with 9 minus 3 is 6, and then 2 minus 1 will be 1, and then we'll have a 1 and a 3. So in effect what we'll have is 100n minus n is equal to 131.6, and 100n minus n is actually 99n. So we've got 99n. That equals 131.6. What we do is we divide by 99. So n equals 131.6 over 99. But we don't want to have a decimal in our numerator. So to get rid of the decimal, we need to multiply the numerator and the denominator by 10. And if I multiply both of these by 10, we'll end up with 1,316 over 990, and what we find again is that this value of n here is equal to this whole number fraction, but we already know that n is also equal to 1.3292929 with the 29 repeater. So again we've established that this repeating decimal can be expressed as a whole number ratio, which makes it a rational number.